This video, we're going to look at simple interest. It corresponds with section 10.2 in our current book. First thing I want to say when we get into this is that I highly recommend that you read the intro to 10.2. It gets into some of the nitty-gritty points about consumer math and personal loans and simple interest. And it talks about things like credit and principal on the loan and security and cosigners and personal notes. And so I would highly recommend that you take a few minutes just to read those first few paragraphs of the section. But one of the things we want to make sure that we cover is the concept of simple interest. And so in order to do that, we need to know what interest is. Interest is the money the borrower pays for the use of the lender's money. Simple interest is based on the entire amount of the loan for the total period of the loan. While there are other types of interest, in this section we're going to focus on simple interest. First thing we want to make sure we know is the simple interest formula. The interest is going to be equal to the principal times the rate times the time. But we don't like to write out all of those words, so we shorten it to I equals PRT. The principal, P, is the amount of money borrowed or loaned. The rate, R, is the rate of interest expressed as a decimal, so it's a percentage that will change to a decimal. And the T, time, is the number of days, months, or years for which the money will be lent. Time is expressed in the same period as the rate. For example, if the rate is 2% per month, the time must be expressed in months. So the most common type of simple interest is actually called ordinary interest. And with our book, it's pretty much assumed that anytime they're talking about simple interest, they mean ordinary interest unless stated otherwise. And the thing with ordinary interest is that we use something that's called the banker's rule. And the banker's rule states that a month is 30 days. There are 12 months in a year, okay? And that, therefore, a year has 30 times 12 days, which would be 360 days. Okay. Now, we know that there are 365 days in a year because some months have 1 month has 28 days, some months have 30 days, and some months have 31 days, and then there's sometimes a year where February is 29 days, and we know that there's kind of that discrepancy with it, but the banker's rule kind of sets this in stone to where we treat the year like it's 12 months. Each month has 30 days, so there should be 360 days. So therefore, if time is given in months, so let's say time is given as 5 months, we would write time as 5 out of 12. Okay? If time is given as 72 days, we would write time in our formula as 72 divided by 360 because we're comparing it to days representing a year or months representing a year. Now, if it's years, you would just say, like 2 years, you would just say time equals 2. Okay? But this is the banker's rule, and this is what we will be using to compute simple interest. So let's look at some examples. We're going to determine the amount of interest earned. So I equals PRT, which means principal times rate times time. To find the amount of interest, we take the principal, which is $425, times the rate written as a decimal. So remember, we have to divide that by 100, which is going to give us 0.0192. And then times the time, which is 6 years. When you multiply those out, 425 times 0.0192 times 6, you get that the interest is $48.96. Let's try another one. In this next example, our principal is $2,500. Our rate is 3 7/8%, and our time equals 2 years. So first thing I want you to do is I want you to take the 7/8 and figure out what's the decimal value of that. So in your scientific calculator, you can do 7/8, or you might have this memorized, which would be awesome. But when you do 7 divided by 8, you get 0.875. So this is 0.875, but it doesn't start with a 0 because we have the whole number 3 in front of it. So what I want us to do first is to rewrite that fraction percent as a decimal. And then we want to take the percent and rewrite that as a decimal. So this 3.875% becomes 0.03875. Whew, that's a doozy. But to find our interest, we're going to do interest equals principal times rate times time. So I equals 2,500 times that decimal 0.03875 times our time, which is 2 years. And when we multiply this all out, we get that our interest will be $193.75. Okay, let's try another. Okay, on this one, our principal is $6,712. Our rate is 6.72%, and our time is 2 months. So remember, that means that we need to represent our time as 2 out of 12, or 2/12. Okay, so I equals PRT. So I is going to equal the principal, 6,712, times our rate written as a decimal, 0.0672, times our time, which is 2/12. When you do this, make sure you put, if you do 2 divided by 12 to get that numerical value, make sure you put that in parentheses just so you don't have any issues with the computations. It should work for order of operations, but I like to just be sure. When you multiply that together, we end up getting that the interest equals $75.17. Now, this actually gave me 17 and then a 4 and a 4, but this rounds down to the nearest cent because the check digit is 4 or less. So that would just be $75.17. Let's do another. Our principal is $1,025. Our rate is 6.2%, and our time is 90 days. So our rate, we're going to write as a decimal, 0.062. Our time, we're going to write as 90 out of 360. And remember, this is based on that banker's rule. Okay, so then our interest equals 1,025 times 0.062 times 90 over 360. Okay, you could simplify this down. That gives us 1/4 because you could divide both by 90. Okay, but I can write it as 90 over 360. That's fine. But again, I'm going to put that in parentheses just in case for my order of operations. Now, one thing I didn't do this round that I probably should do because I like to be consistent is I always like to come back to the formula and make sure that I'm writing it and making sure that I'm putting everything in its proper place. That's going to come up in our next few examples. In our next few examples. So when I multiply this out, I get that interest in this example is equal to $15.89 when you round to the nearest cent. Again, it's 15.8875, but if I'm rounding to the nearest cent, that is the hundredths place. My check digit is 5 or greater, so that rounds up to a 9. Okay, so our interest is $15.89. There are 4 more examples you can try on your own. If you have questions about them, please email me and let me know. Now, in these first 4 examples we looked at, we were looking at an annual rate, Okay, so this rate here was an annual rate, which is why when we had t equals 90 days, we had to rewrite it as this fraction. But in the next example, we're going to look at what happens if our simple interest is calculated with a rate per day. Then we would keep the time in terms of days. So let's look at one. So in our first example, we're going to have the principal be $41,864. Our rate is 0.0375% per day, and our time is 60 days. So I don't need to convert my time because the rate is per day. So interest equals principal times rate times time. So I equals 41,864 times, we're going to write that as a decimal, so that's going to be 0.00375 times the 60 days. Calculating that with our scientific calculator. And our interest value, now notice there are 3 zeros here, not 2. I missed one when I was writing it down, but I added it in, you can see. But when we calculate this, our interest equals $941.94. So when our rate per time period matches our time period, we don't have to do any conversion. But if they had said it was an annual rate and they gave us the days, we'd have to do the days out of the 360. Okay, so now, before I move on to the last set of examples, what I want to do is I want to point out something that's in your book. There's the United States rule that also uses the banker's rule, but it's quite interesting for posterity's sake. If you want to take a moment to read about the United States rule, that is in your book. The other thing you might want to look at is when you have to pay your interest up front, they call it a bank discount. And what you end up having to do is you actually have to deduct your interest from the amount that you get from the bank. So on page, give me a moment, on page 575 in your book, they talk about discount notes and bank discounts. And essentially what happens is if you wanted like a $500 loan, but you had to pay your interest up front and your interest was, let's say, 10%, and you were doing it for 3 months or having the money for 3 months and paying it back within 3 months, they would take and deduct the amount of interest from the actual amount of money that you get. So you're essentially kind of paying that interest up front. So that's just a quick aside. But the last kind of examples we're going to look at is when you are given part of the information, including the interest, and you have to find the other information. So we know our simple interest formula is I equals PRT. In this example, we have our interest, our principal, and our time, and we're looking for our annual rate. Okay, so if I were to replace each piece with what I know, interest equals $82.80 equals the principal, which we know is $1,725, times the rate, which we do not know, but it's our annual rate, which means we're talking about years, and our time, which is 3 years. So what I can do is I can multiply 3 times 1,725, which is 5,175. That's when I multiply these two values together, times R equals the $82.80. To solve for the rate, we divide both sides by 5,175 because that will isolate the R by itself, or solve for R. When we do that, we end up getting, and I'm going to put on a little cloud, that R equals 0.016, which is a decimal answer. We want our rate to be written as a percent, so we multiply that by 100. Our rate equals 1.6%. And again, this process to get from here to here is we multiply by 100. Okay, so let's look at the next one. In this next example, we have the interest is $37.80. The principal is unknown. The annual rate is 2.1%, and the time is 135 days. So we need to do a couple of things. We need to change our rate to a decimal, which would be 0.021. We need to change our time to be in terms of an annual time, so 135 days divided by 360 by the banker's rule, okay? And then we can substitute our values into the equation. So the interest, $37.80, equals the P, which we don't know. We'll put it in orange this time, times the rate, which we have as 0.021, times the time, which is 135, divided by 360. So what we're going to do is we're going to multiply these two values first, and we get 0.00787. It does continue on, but we can kind of round it off there. I mean, the last digit I can add in is a 5, so that would technically round up, but we'll leave it at that. Times my principal, which is unknown, is equal to our interest, $37.80. To solve for our principal, we divide both sides by 0.007875, and we do this on the other side as well to keep our equation balanced. I ran out of space, 0.007875. These will cancel because any number divided by itself is 1, leaving us with our principal is equal to 4,800. Now, our principal should be much larger than our interest, so this answer should hopefully make sense to you. And I'm going to ask that you try the last one on your own. Again, on the last one, you're going to be looking for the time. You're going to follow the same process of substituting the values in, but you're going to be solving for time. The answer that you get for time will be in years, since it is an annual rate. If you get a decimal value, you can figure out how much that is in terms of months or days if you want to, or you could just leave it as a decimal in terms of years. Okay, so try the last example on your own. This is the only video we have for 10.2. It's about 18.5 minutes, but there's only one. So hopefully you enjoy this short and sweet, simple interest video.